Hi, my name is Pun, and welcome to the ITS 227 short video on Pascal's triangle in dynamic programming. Today, we're going to be talking about what dynamic programming is, their two different approaches, and how they differ with their benefits and drawbacks in each. We're going to be talking about Pascal's triangle also, what the method is, and how it can be used in dynamic programming and the code. And after that, my friend will be talking about the remaining steps, that is the structure of the solution with the code and the time complexity of that code, and finishing with the application of this code or Pascal's triangle in the real world. Okay, so let's get on with dynamic programming. We're going to start with the idea of dynamic programming. So the basic idea of dynamic programming is to break down a main problem into subproblems, and we find the solutions to those subproblems using a recursive or non-recursive algorithm, depending on the case. And when we have obtained those solutions, we can then trace it back and obtain the solution to the final main problem. In dynamic programming, there are two main approaches. First one is memorization, or also called the top-down approach. The next one is the tabulation, or a bottoms-up approach. Okay, so let's start with the first one, or memorization. It is a top-down approach that stores the solution of subproblems into an array. And how it works is that we start with the main problem and we recursively solve the subproblems of this main problem. And then when we obtain those solutions, we can trace it back to the main problem. And here in memorization, we store those solutions in an array, and we check each array of the subsolutions to see which one has been solved or which one hasn't, and then we pick that one up to solve. Okay, now the benefits of memorization is that it is easier to code because we can simply use return calls, recursive functions, and condition statements. But the drawback is that when we use those and we check the condition statements of every single items in our array or subproblems, it uses a lot of memory. And then another drawback is that it is slower than tabulation, or our next method here. In tabulation, we use a bottoms-up approach, and the meaning of that is that we start with a main problem and we know what we want to find out. But in the middle is that what tabulation is for. We see if each of the path of the subsolutions lead to the solution that we want. And then we take that path. And then we use the functions and the return calls and the recursive algorithm to solve only this path. And when we solve only that path, it is faster in general because we solve only the things that we need to solve to get the solution to our main problem. But with that, we have a drawback that it is harder to code because there are a lot of conditions that you have to check in order to figure out the main path that leads to the final solution. Okay, that's it for the idea and approaches of dynamic programming. So let's move on to the main one, that is the topic that we have chosen, is Pascal's triangle. So the idea of Pascal's triangle is to create an array or matrix or a triangle, as the name suggests, to find out the binomial coefficients of n choose k. But as my friend will mention later, that Pascal's triangle benefit can be used in multiple ways in the real world. So how it works in Pascal's triangle is that first we start with the element of 1, and the concept of Pascal's triangle is to sum up the adjacent elements of the previous row to be the one to use in the same row. So here when we have a singular number 1, there's an invisible 0 here, but we don't write that in the actual triangle. We just assume that it's there. And what happens is that we take these two elements and we add it together to get the next element on the next row. And the 0 is also here, ever present on each of the rows, and we can use the 0 to add and achieve the next row. Okay, now assuming that the element that we want to find out isn't on the edge of the triangle, we can use the adjacent elements that are in the triangle and add those up, and here we see 1 plus 1, and that equals to 2. And we can repeat this process into our triangle. Here we have the same case at the first row, is that we have a 0 here, and we add it, and then we get a 1. Okay, and after that we can repeat this pattern in order to get the rest of the elements of our triangle. Here, 1, 4, 6, 4, and 1. Okay, now that we have our triangle, let's see how each element in this triangle is represented. First, we have the number of rows. Number of rows goes horizontally, and we count from 0. We have row number 0, row number 1, row number 2, 3, and 4, and so on and so forth. And in each row, we have the number of entries. So here, we have on row number 1, we have 2 entries, and on row number 2, we have 3 entries. And these are represented with k. And we can use that in a binomial coefficient way to find what is the answer to an n-choose k problem, which can also be used with this identity. Okay, so let's see a bigger triangle for this example. Here in this Pascal triangle, we have 7 total rows, or actually 7 ends. Here, 6 and 7. Okay, so let's make up an n-choose k example. Let's say we want to find 6 choose 4. Okay, also can be represented in this form, 6 choose 4. Here the 6 represents the n and the 4 represents the k. N is the row and k is the entry. Okay, so let's find the 6th row, which is here. And then from that row, we find the fourth entry, and we start at 0. So here, 0, 1, 2, 3, and 4. So the answer to the problem of a 6 choose 4 will be 15. Okay, that's pretty much for the concept of Pascal's triangle, and later will be the code and how to apply this in the real world.
Yes, we come to the next topic, the code structure. As you can see, we define 2 functions, the print Pascal, this one, and the binomial coefficient, the other one. And the last part, this one, actually we receive the number of rows of Pascal triangle that user want to create. So, for example, right, if I just want to set the n to equal to 4, right, actually you just went in here, right, and you start the first for loop. First for loop, we actually give out this one, the range 0 to 4, 0 to n. So you actually give out 0, 1, 2, and 3. Then it just hit to the second for loop, right? So it's actually the I in range 0 to line plus 1. So our line is actually this one. So it actually will have 4 loop, right? So the first loop will be 0, line plus 1, so 0 plus 1 is actually 1. And then 0, 2, 0, 3, and then 0, 4. Yeah, just continue like that, right? And in this loop, it actually take the input to the other function that's called the binomial function coefficient. So I will take you through until the 4th line of the Pascal triangle. So from the start, right, we actually have the loop, which is range 0, 1, I 0, 1, this one, which the line is actually the 0, right? So this actually take the line from here, so 0, and then the I is actually this one, right? Range 0, 1 actually have only 0, right? So 0, 0, they actually have nothing in it, so we just return the rest. The rest actually set already initial equal to 1 in here. So next we hit into the second loop, which is the 0, 2, right? This one from here, which we have the 0 and 1, right? In here, it will actually input the I, so we have 2 loop, right? So it will be line which is 1, with the I0, the first one, and the 1 and 1, which is actually the binomial that I just write in here. So at first we check the if statement, right? Which whether the k equal n minus 1. Oh no, sorry, larger than the n minus k or not. Which from this one, right? It actually no, because not 0 is not larger than 1. So we just skip it here. And we just hit the k is equal to 0. Oh, sorry, this one is actually wrong. So it is actually just hit this one, which this one have nothings in it. So it return 1. And then next, right, we just hit the second for loop, which is the 1 1. And then we check again whether this one is actually more than the 1 minus 1. Which actually, yes, right. So we set the k to be 1 minus 1, which is 0. So it's actually 0 to 0, which this one is actually wrong again. So will be 0 and 0i. So this one also have nothings in it. It also return 1. So now we get into the third for loop, which is the 0 3 from the for loop of the print Pascal one. So we are in the second line, right? With this one actually we have 0 1 and 2. So we will have the 0 2 0 2 1 and then 2 2. This one, and actually the other 2 2 will be on the next page. So we start again, check the if statement, which actually this one is 0 is not greater than 2. So no, just give it. And then k is actually 0 0 0. This one is nothing yet, which is right. So we return 1. Right. And then the other one, the binomial 2 1. We also check again, which this one is no. The k will equal to 1, right? So 0 1. And then inside the 0 1 we have only 0, right? So we take the rest, which this one is actually the initial one from here, hit into this one. Take the n minus I, which the n is 2, and the I first, which we only have 1 is 0, so 2 minus 0. This one we actually give the output is 2. And then this rest, right, we take this one to that one, to 2 with the double slash divided by the 1. So 2 divided by 1 is equal to 2. It's actually return 2. So you must remember this one, 1 and 2. And next, right, this one is the 2 2 that is talked about just now, which we also check again, which 2 is greater than 0. So yes, right, we set the k equal to 2 minus 2, so n minus k. It actually gives the loop 0 0, so nothings, and then return 1. As you can see, right, just now we have the return 1, return 2, and then return 1. And the second one, actually we have the return 1, return 1. And the line 0 we have return 1. So now we looking at the Pascal triangle is actually building up, right? So we only have one line left. So next. Finally, we come to the last loop of the Pascal print, which is 0 3, which contains the 0 1 2 and 3, right? So in this the third line, which actually like the fourth line, right, we'll have like a lot of binomial one. So the line with 3, right? So if we have 3 0 3 1 3 2 and then 3 3. So we have 4 of it, right? We do it again like this. Check the if statement, which is no, and then we just hit the for loop like this one again, like recursive things. So return 1 3, and then we go to the next page, see again. We also do the same, the 3 2 and the 3 3. We get the 3 and the 1. So in the fourth line, we actually receive like the 1 3 3 1, and just now the 1 2 1 1, and then the 1 1 and then 1. So now we got the Pascal triangle, which is 4 line. As you can see, n equal to 4, right, row. that's it for the code structure. So this topic is about the time complexity, which our code, this one actually give out the big O of n to the power of 2. The time complexity of the print Pascal function is approximately this one, the big O n power 2. Since the outer loop runs n time for each iteration of the outer loop, the inner loop may iterate up to n times. However, the actual times complexity might be slightly less due to the fact that the inner loop's iteration decreases as line increases, but it doesn't change the overall complexity order. So this one actually the the time complexity of it. Just now we do the presentation on the iPad, right, which is the slide. So now here's come to the computer laptop, which I will demonstrate the code that just now I showed in the iPad to you, the same chunk of code. So let's run the code one and enter the role of the Pascal triangle. So we just put like 4 just now that I calculate in the slide, right? So hit and enter, and yeah, this one, the same Pascal triangle that we just calculate. And in this chunk of code, right, we can actually like hit in like uh a lot of like really high value of number of row, like more than 100,000, but I would demonstrate to you like just 10 first, like this one, and we also land like 100 also can, this one, which actually a lot, and now it is busy and like really hard to see, right? Yeah, so this is how they code one. In the real world, Pascal triangle translates into the complex topic of graph theory, where includes turning mapping information into data, finding structured paths, airplane rules, and airport control, computer graphics, engineering, data management, search algorithm, which also have like many much more things that Pascal triangle can apply to. And as you can see, the chunk of code in front of the screen, right? We just coming up about like the specific math question in like the high school one that's asking us like in this row, like the fourth row, second column, what is the number of it in Pascal triangle? Which I use the Pascal triangle and the coding to apply to this one. As you can see, we start running the code, right? Please input the row. Just now I say the fourth row and then the second column. And this one we're giving out the code. This one, the number 3. So the 3 is actually located in the fourth row, second column. And like you can actually go for like like the like 100 row in the third column. It's actually the number 4851. Here is another example of how Pascal triangle theorem can apply to. This one is a graph which we use the Pascal theorem to find the shortest path. How many shortest path from the point A to the point B? And the length of this cube, right, actually equal to 1. So this is 1, because we have one way to go there. This one is 2 because we have 2 way. And this one also 3 because this one we have these 3 way to go to it. And the amazing thing is that you can see that the 3 is adding up from 1 and 2. The 2 also adding up with the 1 and 1. And in this graph, right, you go from the A to B, you have 51 paths to choose. And here is all about the Pascal triangle theorem, and thank you for listening.